Welcome to the Profile Corner. Today's video is part 12 in the Introduction to Woodworking Routers series, part 3 of using a router table. In today's video we're going to be using the upgraded router table from the last video to create various things. We'll start out with creating a rail and style raised panel door of a certain size here that I've sketched out. I'll bring this up a little bit closer so that it's easier to see the sketch that I've created of it. Basically, the door that's going to be created will be 14 inches wide, 18 inches tall. The stiles will extend from the bottom of the door all the way up to the top of the door. The rails will be positioned in between, and they'll extend into the stiles slightly. And the distance that they'll extend in could depend on the router bit that you're using. I'll be using a white side router bit for rails and stiles, and all those that I've seen, that I own anyway, require 3/8 of an inch. They'll cut in other words, 3/8 of an inch into this board. So this has to be 3/8 of an inch here, and this has to be 3/8 of an inch here. So the stile will be 18 inches long. The rail will be 14 inches minus 2 inches minus 2 inches, so that brings us to 10, plus 3/8 plus 3/8. So that would be 10 3/4 inches is going to be the total width of this rail, or the total length of the rail for that matter. And then the raised panel, which will go into the middle here, that'll be essentially the same width as this rail is long, minus a little bit to allow for expansion of the board that'll be put into here. And then the stile will determine the length of the raised panel that will go into here. So it'll be 18 inches minus 2 again, so that's 14 inches, plus 3/8 plus another 3/8, so that'll be 14 3/4 minus a little bit for expansion. Now raised panels won't expand much up and down, so we could probably just subtract maybe a 1/16 of an inch, whereas going across we'd probably want to subtract at least 1/8 of an inch, so that would be a 1/16 on each side. So let's get started. I'll cut down the boards to the correct sizes, and then we'll jump over to the router table and we'll start the milling operation there. I've had to make some adjustments to the router table here. The Milwaukee router that I had in here, which I thought was a 3.5 inch diameter router motor, I measured that router motor and it actually measures 3 5/8 inches in diameter. So there was a small gap right here in the curve, and over on the other side of this I had added in a shim right here to try to tip the router motor back in that direction. I noticed that the router was quite noisy, and that's more than likely because the shim that I had in here was only point of contact in this strap. And then on this other side, the only point of contact was probably the back portion of this upper guide. And so that was probably causing a lot of vibration. And I was concerned that when I inserted a 3.5 inch diameter panel raising bit into this, that having that essentially tilted at an angle would cause quite a bit of problems, especially with the low points of contact. I found that I've got a Portacable 890 router that has a correct diameter motor, and also there's a little bit of additional height here compared with the 690 model series Portacable routers. And so what that means is that I'll still be able to change the router bits above the table, which is nice. And also this has a speed control dial built into it, whereas the Milwaukee 2 horsepower router did not have that speed control dial. So I think this will work out to my advantage as long as this motor doesn't burn out anytime soon. This is a motor that I got from an eBay seller. It sounds like it's still in good condition. I'll have to plug it in and test it out and see how we do with it. I still need to verify that when I insert the centering bit into this, that it's actually going to be centered. And it looks like right now this router only came with a 1/4 inch collet. So I'll have to try to get a 1/2 inch collet. I put a couple on order. I'll have to get one of those and see if it fits into here. And then also make sure that the wrenches that I've got for the porta cables fit that, the collet nut for that 1/2 inch collet. It's my understanding that the collet nut is a metric size rather than the normal imperial size nut on the replacement collets. And then we can get back to doing the raised panel doors. I have the boards laid out for the door, essentially how they'll be arranged. And what we'll need to do is to cut into the end grain of the rails using one router bit, and then on the inside here on all 4 boards we'll need to use a different router bit to cut a slot for the raised panel. So let's take a look at an example here of one that I cut quite a few years ago. You can see that the profile on the end has a tenon here that'll fit into a slot that's cut on the inside of all the other boards. So what we need to do is we need to figure out which router bit needs to be used. This is a set we'll be using. And so we want to start out with the end grain on those rails. So we need the router bit that's not going to cut a slot in the center. This router bit right here is going to cut a slot in the middle, whereas this one here has a bearing in the middle. So we'll want to use this router bit. And because the profile for the face of the door is at the bottom of this router bit, that means that we need to run the boards through the router bit with the face side of the board down to the table. So I'll mount this router bit into the table. Next, what I need to do is I need to set the router bit height. Right now, the top of this cutter, which is about 1/4 inch in height, is exactly level with the board when I bring it over. I don't want that to be the case. I want this bit to be about an 1/8 inch above the surface of this board, because these boards are 3/4 of an inch thick. What that means is that there'll be a 5/8 inch height difference for the panel that'll go into this if the panel is going to be flush. That's if we have this router bit an 1/8 inch above the surface here. And so I'm going to raise it up. I have an 1/8 inch setup block here to help me figure out when I get to an 1/8 of an inch. Okay, that looks good right there, and it's flush now. Okay, so I can remove the height adjuster. Next, what I need to do is I need to get this bearing so that it's flush with the fence. So I've got the fence unlocked. I'll bring the fence forward. Make sure that it can turn. Okay, it's not able to turn. Okay, so I've got a problem here where it's running into the fence. So, and since I've got the height set right, I need to clearance out the fence a little bit. So I'm going to put on my glasses, hearing protection. I've got it plugged in. So I'm going to back this off a little bit, and I'll turn it on, and I'll bring the fence forward. Okay, I've clearanced out the fence. Now I can go back to what I was doing here. Put the ruler in front, bring the fence up, till it makes contact. Lock down the first side, make sure that the fence is flush. Okay, spin this bit, and the bit still spins freely, which is good. Okay, we're still centered there. That's good. Okay, so I need to run these short boards through, and it's going to be a little bit dangerous to try to hold that when we get out into here and go across. So what I've got here is an MDF board that I've cut so that it's longer than it is wide. So that should make this operation safe. Move these boards out of the way temporarily. So this should be a safe operation if we use push blocks to push it through past the router bit. And so I've got that set. So let's go ahead and we'll get started here. using this backer board also helps to limit the amount of chip out that we get when we're doing these cuts. So here's one of the two boards that we created. The copes on the end. Okay, so now we're ready to switch over to using the other router bit so that we can cut the profile on the inside edge of the boards. So that profile will be cut on this edge right here on this board. Need to lock down the center insert here, and then I need to set the height of this router bit. First of all, I want to bring it over close, and what I'll do first is to bring this over. This is a side piece, and what I want to have here is that the top of this tenon here has to match up with the top of the wing of this router bit right here that's going to cut the slot. So the top of the tenon has to line up with the top of that portion of the bit. And we're up just slightly, so I'll lower it down. Okay, so we're up just slightly. I'll lower it down. Okay, we're still up a little bit. Okay, that looks good. And doing this operation, even with the router lift that I created myself years ago, would be incredibly difficult without a good quality router lift like this one. So this is really saving a lot of time because it's very easy to fine tune this. As a matter of fact, this is up just probably a thousandth of an inch too far. Crank it a little bit more, and now the ruler slides right over the bit, which is what we want. But we don't want to just trust that. We actually need to test it using a board that's the same thickness. So I've got a board here that I've previously used for another test. So I'll use this to verify that the height is set correctly. Okay, so after setting the height correctly, we need to take another step and actually set the bearing here so that the fence is lined up with it before we can actually do a test run using a test board. So we'll get the ruler again and we'll put it across the front of the bearing, bring the fence up. Okay, lock down the first side, verify again, it's lined up, lock down the second side. Okay, so we're ready to turn on the vacuum and the router and do a test with the test board. Okay, so here's the test cut that we just made right here. Let's see if our test board fits into it. Okay, and it does. And that appears to be a perfect match. It's flush on the surface and it lines up nicely. This white side kit does a very nice job of matching the two bits together to make a profile. Okay, so now we're ready to cut the inside of all 4 pieces. And I have marked on the 4 pieces which side goes against the fence. And if I can read that, where it's written right here, then I know that this is the inside of the door and this will be the front side of the door, so I don't get things mixed up. And I want to make sure that the profile is going to match on the end with the profile that I'm cutting also, that I'm not cutting on the wrong face. Okay, so I've got one of the boards here, I've got another board, and then the other 2 boards are right here. I got to make sure I've got them all oriented correctly. Front, face, fence. And this one also says fence. Okay, so we're ready to go. I'm not using any hold downs, but I'll be using the push block to send it all the way across. And for the longer boards, I'll use 2 push blocks. Okay, so there's the cut on all 4 of the boards. Let's see if they fit together. Okay, that looks nice. Okay, they do all fit together and they look nice and they're flush on the top, just like they're supposed to be. Tape measure here, and let's do a quick measurement. Okay, that's exactly 14 inches across, which is what it's supposed to be. Here you can see it's 14. And then this direction, it's supposed to be exactly 18, and it is. So now, all that we've got to do is we've got to create the raised panel that goes into the middle. And that's going to require a very large router bit to go into here. The router bit is 3.5 inches in diameter. And this is the router bit that we'll be using. So we don't want to spin this router bit at 25,000 RPM. That would be way too dangerous. So I need to slow the router down to somewhere around 10,000 RPM. if your router does not have multiple speeds, there's a solution to that. You can get a router speed control. I believe this one is made by MCLS. I purchased this one probably more than 20 years ago. And what it does is effectively slow down the speed of the router by decreasing the voltage going to the router motor. Let's see if I can plug the router into this, and then we can do a real quick test. I'll actually be using the speed control to slow down the router. That speed control is built into the router itself, but I'll use this as a test. Okay, so I've got glasses on. Let's see if this works with this router. We'll turn it down. Apparently it's not compatible with this router, which is quite odd. So that's okay. We'll just use the built-in speed control, but this would work with another router. I can insert a video clip that shows how this works with a Milwaukee router. Okay, I'm going to turn on the switch down here, which is unfortunately, there's no way of knowing how fast it is. However, I do know, just from experimenting just now, that if I move this dial all the way down to the minimum value, it actually shuts the router off. Okay, so we need to cut the raised panel next. And there you can see that we need to make this raised panel, looks like 5/8 of an inch or slightly under, so that the raised panel will actually sit flush with this surface here. So this surface back here is exactly 1/8 of an inch, and including the tongue height, that should bring us to 5/8 of an inch for the height of the raised panel. So I'll get that raised panel board milled down to 5/8 thickness, and then I'll bring the camera back. And also, while I'm doing that, I'll adjust the speed of the router down to 10,000 RPM so that we're ready to go with the raised panel bit. Okay, now it's at 10,000 RPM. So that'll be safe for that large router bit. Okay, the board that's supposed to go in the center of this door is supposed to be exactly 5/8 inch thick by 10.5 inches by 14.5 inches. I have a board here that measures those dimensions. So it's exactly 10.5 inches wide. And then it's exactly 14.5 inches long. Okay, I have the raised panel bit mounted into the router, We don't want to take this off in a single pass because this bit is very large and that would put a very large load on the router motor that's in here, so we don't want to do that. So this router bit does not have what's called a back cutter. So in other words, it's not going to be cutting a slot on the underside or the top side, whichever happens to be the case. So what that means is that I can either set the bit height correctly to whatever the desired final height is, and then move the router fence inward to achieve the little bit of cut that we want to take in each pass. Or what I can do is I can lower this router bit down and then take a pass and then raise it up again and take another pass and then stop once I get to a 1/4 inch thickness remaining in the board. And that 1/4 inch thickness will be for the tongue that's going to go into the other boards to hold this in place. And then in that gap, we'll be filling it with a product called space balls. So we'll be filling that 1/8 inch gap between the edge of this board and the inside of the slot with a product called space balls. These are specially designed to allow this board to expand slightly. And then once this board is milled, what you'd want to do, because it's going to expand and contract, is that you'd want to finish this board before you glue the door up. So that way if it shrinks down slightly, you're not going to see an area along the edge here where the finish is not applied. So these space balls will be taking up the gap that we're along 1/8 inch on each edge. Okay, so I'm going to drop this bit down and then we'll get started. But I've got a slight problem here in that this bit is 3.5 inches wide, which is wider than the gap I've got in the fence. I do not want to cut a 3.5 inch wide gap in the fence because then that'll make it hard to use this fence for other purposes. So what I've done is I've created a sub fence that I cut at the bandsaw here so that there's a little bit of a relief for the router bit to ride in. I may have trouble where I can't raise the router bit up as high as it needs to go without cutting this height further up. This was originally cut for a more shallow center panel than what we're using here today. So I may have to stop at one point and take this over to the bandsaw and open this up a little bit more. So this sub fence will go in here, mounted onto the front of the fence. And so what I should do is I should bring the regular fence up behind it, use the ruler to get the bearing in the right spot, okay, so now I can lock down the main fence. Okay, so is that bearing still aligned? Yes, it is. Okay, so that's good. So now what I can do is I can lock this sub fence down to the table just using some cheap clamps. You could use a C-clamp, or if you've got some of these, they should work also. Okay, lock that down. We'll verify again. Okay, that's still aligned, so it hasn't shifted on me. Okay, check it one more time. Okay, that looks like it's still lined up with the bearing, so that's good. Okay, so now the only thing that we needed to do is to drop that bit down so we're not going to take such a heavy cut. Just want to take a light pass on the first go here. Okay, let's see if we can get an idea of how much will be cut off. Okay, that's about 1/4 inch there. So let's go ever so slightly more shallow. Okay, so one more time. Okay, so that may be a good starting point right there. And I'll be using the push pads once again to hold the board down to this surface. I could use some other methods to do that, to hold it down. I could use some other methods to hold it down, but this should work out pretty well. And I want to cut the end grain first. I got to make sure I've got the side that's going to be exposed on the front of the door down on the table. So I think that this face here looks a little bit nicer. So I'll put that down. And now we should be ready to go, as long as the router is going to spin at the right speed. And we'll just double check it real quick here to make sure it's down at 10,000 RPM. And it sounds like it is down at 10,000 RPM. Cut. It looks nice. Okay, so there's the first pass all the way around, and it looks like it's just barely starting to leave a relief here, so that's good. I'm thinking that what I want to do next, let's see how deep it is here. Okay, we're at about 5/8 of an inch right now. Excuse me, we're at about about 3/8 of an inch right now in thickness of the tongue. So I need to take off another 1/8 of an inch. Okay, so I'm going to raise it up I'll raise the bit up about 1/16 of an inch and I'll make another pass. On this router table, each revolution is roughly 1/32 of an inch. So I want to make 2 revolutions. 1, 2. And then we'll just check it here. Make sure it still spins freely, and it does. Okay, let's take a look here. Okay, that looks like that's going to be taking off 1/16 of an inch. Okay, so here's where we're at now. It's looking pretty good. I don't know why we're getting a little bit of a roughness here. If there's just a jump in the bit or just what, right there. But it's getting very close to being at the final thickness now. As you can see, we're probably just 1/32 of an inch thicker than 1/4 inch at this point. And it does look like we're about 1/32 of an inch away from 1/4 inch. So that should be 1 turn of this handle on the router table. Okay, we're ready for the final pass. Okay, so that should be the final pass, and let's see if it actually fits together. Here's one of the side boards style, and it does go together very tight, as you can see right there, which should be a perfect fit. Let's see if we're able to assemble the finished door. Okay, I simply had to take this door over to my workbench and just make sure that I had the pieces here in the right location. I had this piece a little bit too far this direction, and that was making it difficult to put it together. It just slid right together like nothing. And that looks absolutely beautiful all the way around. The only thing that I did not do is to, of course, glue it up. I haven't glued it up yet, and I still haven't put the space balls into this area in here. And I need to do that so that the center board doesn't shift around as it contracts, so that those space balls will help to take up the space to minimize the amount of noise that the door makes in use. Okay, and of course there's a 1/8 inch space on the inside here all the way around to allow this board to expand and contract as necessary. And of course it won't expand this direction along the grain, but it helps to allow for a consistent reveal all the way around. Okay, that's all for today. Thanks for watching. Bye.